Today's session is about deploying Fujitsu Enterprise Postgres as easily and quickly as you can, probably more easily and quickly than you can imagine, through our integration with OpenShift on the IBM zLinux platform. Now we have two flavors of this. Obviously, we have the traditional Z platform where we can also stand up Linux environments, but we also have the dedicated Linux One environment platform, which is only for Linux workloads. So you will see an interchange of both as we talk through, and that's the pictures that you see here, both from Zeus and myself. Zeus comes from the Fujitsu side, and he's a sort of specifically an expert in terms of deploying, and he's actually has a hands-on, has a hand in actually getting their Fujitsu Enterprise Postgres software stack running up and running on OpenShift and having it ready on the platform. IBM has been working quite closely with Fujitsu on this and other engagements in terms of how best we can deliver secure data serving with Enterprise Postgres from Fujitsu's software teams on this particular platform. Very loose agenda today. As I said, I will very briefly cover the partnership that we have with the Fujitsu Software Business Unit, as well as why the IBM Linux on Z platform has been selected as a primary target for deployment and for integration from the Fujitsu Enterprise Postgres side. And then we'll quickly switch to the demo where Zeus will cover the ease of deployment. And obviously beyond the deployment comes the day two operation, how do you do upgrades and so forth, and updates to the Postgres configuration, how do you obviously do the database level stuff that you need to do, including things like configuring for HA solutions, automatic failover, and for specific features like data masking that you can do. And then we will have the Q&A at the end, but if there is some sort of burning question, feel free to just drop it into the chat window. We will get to that, but if you need to raise a hand and want to ask something specific, feel free to do so, and John will interrupt us. In terms of our, as far as the two organizations go, we both are, firm commitments to open source. We have been partners in open source in general. We have been contributors in the open source world, from everything from Hyperledger to the Linux Foundation on multiple platforms. In terms of what we're doing together, we bring a synergy of certain capabilities. One is the Red Hat component, which we will cover today, which is specifically around OpenShift, but also specifically the platform level. We enable providers such as Fujitsu's Software Business Unit to take advantage of built-in transparent, built-in security in the platform, as well as scalability and performance, and a level of containerization and ease of management that doesn't exist on most other platforms that are from a competitive perspective. So key capabilities very quickly. This IBM Linux One or the IBM Z platform is the only platform that has these particular capabilities. One is 100% data protection, and we're talking about encryption of data in flight, at rest, at a network level. 100% key protection for those that require key management of whether it's crypto, whether it's just your master keys that you use for your data encryption, which Fujitsu Enterprise Postgres currently uses already, as well as 100% audit readiness, and the only platform with EAL5+ isolation between VMs, between our LPARs that we can actually deploy, which is the equivalent of air-gapped servers that have actually been deployed into separate physical racks. You can do that level of isolation on the one machine between VMs, between LPARs, between ZVM or KVM deployments. And in terms of resiliency, a single server by default delivers up to 4 nines availability in a frame, but can be architected to 5 nines. That should actually be updated up to about 7 nines. Some of the banks do their core banking on 7 nines architectures using our geographically dispersed parallel sysplex architecture, or GDPS. And that specifically delivers 7 nines availability when required. In terms of performance, there is no other platform that can deliver this kind of throughput for both, database backups for business continuity, as well as data serving through the I/O stack that we have in the back. In terms of, again, performance in a single frame, we are talking about 6.2 billion transactions in a single frame, up to 377 billion transactions in a day in a quad frame. And in terms of, obviously, response time, we're talking sub-millisecond responses. It is designed for large-scale NoSQL, as well as such as MongoDB. In this particular instance, talks about as a reference, Fujitsu Enterprise Postgres can deliver obviously enterprise-grade Postgres capabilities, which Zeus will talk about, and obviously can easily match that as well as deliver the same level of performance and take advantage of that. Overall, one of the key capabilities of this platform is the TCO capabilities in terms of reduction, because of its throughput and its performance and its very specific architecture, which I won't go into too much detail about, which we may do at a different on one of the other sessions, either this month or in the following months. We are able to actually deliver a far greater granularity of both resource allocation as well as performance per call. In fact, this particular platform, both the Linux One as well as the Z platform, can be driven to a sustained utilization of 90 to 100% in most cases, which an x86 equivalent cannot. For the simple reason, we actually have dedicated co-processors for doing other workloads such as I/O traffic, encryption, cryptography, so forth. So we dedicate the CPU and the cores specifically for your workload that needs to be executed here. What does the Fujitsu Enterprise Postgres actually take advantage of directly from this platform? We are talking about, as I said, workload isolation. And by default, you get multi-factor authentication capabilities on the consoles, but also firmware tamper protection capabilities as well. Secure boot is something that will be more and more important these days. What you deploy as a secure image, even through OpenShift, can be signed in a way so only signed images can be deployed. That prevents injections of backdoors, malware, and so forth. And secure execution for Linux, as I said, is at a hardware level as well as in memory. It prevents potentials for leakages and so forth, but also protects what you run in terms of data through your memory, in code, in use code in memory, as well as within the LPARs themselves. And as I said, we have on-chip crypto with its own co-processor that handles all the cryptography. Now, we won't cover this today, but Fujitsu Enterprise Postgres does leverage the ECC as well capabilities going forward on this platform. As we said, we're going to talk about OpenShift deployment. So let's very quickly cover our synergies through our Red Hat acquisition. And we are now the platform that can deliver true hybrid cloud for both applications as well as data transformation and data serving out of a hybrid cloud or a multi-cloud environment through our acquisition of Red Hat. Specifically, it underpins and is the foundation for what we deliver for multi-cloud management, and that is an important opportunity there for you to leverage, for instance, your on-prem Linux One or zLinux environment as your core secure environment from which to actually push out your images and your containers and your microservices, all the way into any cloud provider that you wish to use, public or private. That includes the IBM cloud as well. But obviously we leverage Red Hat OpenShift as the orchestration layer, and IBM adds certain capabilities, which I will show in the next slide, specifically around what we call the cloud packs. I won't go into too much detail again, but we'll probably run a session on that another time. But that underpins the capabilities that you want to deliver both from an application as well as a data serving perspective from an enterprise perspective that you may wish to leverage. Specifically, this is just a way of how we deploy Red Hat OpenShift on the Linux One, just a quick overview. It is very traditional to how you might do on any other platform. However, the key differentiator here is the fact that you can leverage things like the TKE, which is a trusted key entry system, to do further levels of encryption at the data layer on the database or your application layer through using our HSM, but also you can quickly deploy these cloud native applications with a lot more speed and efficiency. You can standardize what you do with your hybrid or multi-cloud environment for both Linux workloads, containers, and microservices. The IBM Cloud Pak specifically delivers some pre-built containerized software stacks for both applications, data integration, and multi-cloud management that will actually let you manage your multi-cloud environment with a lot more ease and efficiency. The last 2 points are important. We build with the multi-cloud, multi-R containers, which means a single image deployed on a Linux One or Linux zLinux through OpenShift can also be used on an x86 platform. So you do it once and you deploy it anywhere. And the last piece of this puzzle is, as I said, 2 things. One is very low granular resource allocation capabilities on this platform means your worker nodes can be allocated to be as small as less than 1% of your of a CPU or memory core that you have. And that means that you have much leaner hardware requirements, and that by default means lower software costs. Typically, we find that one Linux One or Linux on Z IFL, which is what we call in our core, dedicated for Linux workloads, is the equivalent to probably 20, between 10 and 20 x86 cores, depending on the workload that you wish to deploy. So now we go to the demo. I'm going to have to end the show first and then hand off to Zeus so he can do what he needs to do.
Thank you, everyone. Thanks, Anand and John. Good morning and good afternoon, everyone, depending on where you are. My name is Zeus and I am the Principal Solution Architect for Fujitsu. What I'm going to show you is how easy to deploy the Fujitsu version of Enterprise Postgres onto the OpenShift environment. So just give you a little bit background. We have been developing Fujitsu or the Postgres software for a long time. So lately we have certified our product onto the Red Hat OpenShift catalog. So what you can see here is the Red Hat OpenShift catalog. And if you go there, search for Fujitsu, and you'll be able to see our Postgres operator here. So having the Red Hat certification will give the customers the confidence that we maintain our software. We have been investing on this software for a long time, and it can be deployed easily. So I know like a lot of database administrator has been asked before. I want to move my workload into the container world, and I'm just not familiar on how to do that. And especially if I want to set up a high availability cluster, that seems to be quite challenging. So this is where we come in. We use the industrial practice by using an operator to deploy our database, and it will provide you the various functions like high availability data operations. So this is the OpenShift console. So if you come into this console and if you go to the operator hubs, since I mentioned that our operator is certified, click on certified type and search for our name, Fujitsu. Again, you'll see the same operator screen that you see on the catalog. Click on that one and click install. And the good thing is our operator can manage multiple namespace. If you're not sure, you can ask question later on, but basically in a Kubernetes cluster, you have different namespace similar to a project analogy that each team can have their own environment to deploy things. We can deploy it on one particular namespace. That means this operator will only control the Postgres cluster within that namespace. So let's just say you have an HR department and you have a DBA responsible for that department. You can deploy an operator into that namespace, and all the database controlled by this operator will be restricted to that namespace only. Just saving time, I'll just start to deploy this operator. Behind the scene, it will take probably around a minute or two to finish the installations. If you come here to look at it, you will see that it's it's already started creating something we call a Kubernetes port. Basically, it's our where we run our operator in this particular namespace. So it does take a little bit of time, but the process is quite easy. While we are waiting for that to finish, I'll do some preparation work here. Okay, so now you can see that it's running. That means it's ready to serve and let you create a cluster. So if we come back to this install operator and click on our operators, so there are a couple of things you can do here, but the most important one, which I'm going to show you, is the FVP cluster. So we give that a name. Throughout the presentation, you'll hear a lot of FVP. That basically stands for the Fujitsu Enterprise Postgres. So we call our Postgres deployment as a cluster simply because you can deploy a standalone database, but at the same time you can deploy a HA solution with one master and multiple replica in the solutions. The good thing about our deployment is you can do it via the GUI, which is you have a YAML file here, and you do a click create here, and then you can do the deployment. But at the same time, we know there are a lot of people, they are relying on their CI/CD pipeline, or they are more comfortable with shell scripts or other utility. You can do the same thing with command line or CI/CD pipeline as well. So the same deployment file that I have here, it's basically the same file. I provide as a YAML. I can do it on the command line. So what I'm going to do is I'm going to demonstrate to do it on the command line. All right. So that process is starting. And you can see that is starting the deployment. I call my database cluster as FVP demo. So now you can come and look at the event. So there will be new events coming in while it's doing the deployment. The deployment itself take a little bit while. It could take like up to 4 or 5 minutes to complete. While it's doing the deployment, I'll expand a little bit on our YAML file, the deployment file. So that's what I'm calling. My database is called the FVP demo. I want to have 3 instances. So when you deploy the cluster with more than 1 instance, basically the first one will become the master, and the remaining instances will become the replica. You can normally what kind of replication it is. So by default, our recommended replication mode is sync replication. That means like one of the replica will have a synchronous replication to our master database. And by doing that, you basically have some very minimal chance of losing data because database will actually synchronize the transaction across to the replica before it finish commit. So inside this configuration, you can see that you can actually customize the PGHPA configuration. For those who are familiar with Postgres, PGHPA is the kind of security mechanism to determine who can connect to my database, what kind of authentication that database, that connection should be using. So this is one way you can actually customize your PGHPA. If you don't do anything, if you don't supply anything here, like what we have here, we have a default rule that say all connection to a database, it prefer to have secure connections, SSL, and all connection must be password authenticated. Even if someone log into the port itself, they must authenticate to the database. And the next part is we also allow all of you to customize the Postgres parameters. I'm not going to explain every single parameters, but basically, like, there's something called work memory, maintenance work memory. Those are the kind of like the memory reserve for how you want to tune the database, such that it can perform a better loading. And then there are a couple of other parameters that you do here. We also create separate volumes to store different data. So traditionally, people put the whole database into a single volume or hard disk. So the database files, their transaction logs, and even the database logs are on the same disk, and that can hammer the performance quite a lot. We provide a facility that the customer can nominate the volumes. As we can see here, we can say like we have a data volume that stores your database files, and then we create a separate volumes that store your transaction log, which we call it val volume. And then we have some log files that we generate from the database and put it into a separate volume. If you want to do backup, our operator can actually help you do backup as well, and you can put a separate backup volume into the solution as well. So now our database is deploying well, so I'm going to show you here. We've finished 2 database port here. They're all running. There's 1 port in the database, and it is running. The third one is still deploying, so that number is 0. Now let's have a different look on this one. So I'm running this little shell scripts that basically monitor our environment, and you can notice that the first one that comes into the cluster is the master, and the remaining 2 are the replica, as I explained earlier. Okay, so let's simulate a client connections to the database. So I'm using the pgmin to do that. All right. Before I explain further, let's come back to here and look at the networking side first. The reason behind that is like when we deploy our cluster, we create 2 Kubernetes service. One is the primary service, one is the replica service. So the good thing about this service is it follows where your master is. So if I click on this service, you can see that it's pointing to the STS0 port. STS0 port is our master. And if we come back, replica, and you can see that it's pointing to both STS1 and STS2 here, which are the replica here. So if I come back to my pgmin, which I'm set like try to simulate a database connections, you can see that I connect to the primary service, and then I have the replica service here as well. Just focus on this primary service. You can see there are a little bit of transaction happening, and if you look at the sections, you can see the 2 replica actually connect to this primary master database. So we finished the deployment. I think it takes around 5 minutes to do that. Now the next thing is I finished my deployment. I've been using my database quite successfully. However, I found there's some bottleneck, or there's something that I want to tune up my database. So how are you going to do that? Quite simple. We come back to the operator, click on the cluster that we have, go to the YAML. Again, I stress that you can do it by the GUI. Alternatively, you can actually edit the YAML file and then apply again. So to demonstrate that, what I'm going to show you is some parameters in the system. So notice this one, the 0 damage pages. I'm just randomly select one. The current settings is actually off. So I'll come to my GUI, go to my configuration, and you can see this is where the session that I can put my Postgres parameter here. I am going to add a line here saying, oops, copy and paste. Just give me a moment. Just type it. All right, so I have finished editing this parameters. I'll save it. And the system, because this changing this Postgres parameter doesn't require restart of the database. Behind the scene, it will apply the changes gradually. It takes a little bit of time again. It takes a little bit of time, but it will apply at the back. So we'll just keep on refreshing the screen. Just pay attention to that line. It'll probably take a minute because our operator will iterate on the database cluster every 30 seconds and then check for any changes and then apply. All right. What we just see that this data change has been done. Now it's on. So previously it was off, now it's on. And you can see that the database is connected at all time. So that basically helps you on your day-to operation. You want to change something, you want to tune it up, you can do it. Of course, there are occasions that you need to, some parameter change requires you to restart the database, and that can easily be done by just deleting the port, and when it restarts, it will get the new parameters. Now, the next one I'm going to show you is a HA scenario. So every now and then your database like may crash due to whatever reason, and in the past you have to actually do a lot of corrective actions in order to fail over your database to different machines, what we call now as support on the particular node. So I'm going to simulate a failure. Just remember this SDSU is the master. So I'm going to delete this one, and I'll keep deleting that. And just, I know the screen is a little bit small, just keep watching on this column. I'll just keep deleting it. All right, so you can see something has happened. So that one, I keep killing that database, and you can see that the role of the master has been switched to a different port without me doing anything at the back. And that one will come back eventually. When it comes back, it will become the replica. So it will start replicating from this new master. If I comes back to my PG-amine, so basically the PG-amine is to simulate our client connections. And because the PG-amine has the reconnect facility, when my master actually dies, the connection was dropped for a momentary period of time. But when the master comes, or the new master comes back, this PG-amine will reconnect to our database, and you can see the statistics keeps coming. What I'm going to show you again is, remember I mentioned about the service, this primary service. You can actually see that now it's pointing to my new master, which is the STS2. So what it means is this primary service at all time is connecting to this master database. Yes, if there is an outages on our system, the good thing about that is the database will automatically switch to a new one. So there's a momentary outages on your application. However, if your application behaves just like the PGME, it will retry connection back to the database. It will reconnect automatically, and that actually is quite seamless to your user. Okay, so I've showed you, so far I've shown you how easy to deploy your Postgres, how easy it is to change the parameters, and how our solution can help you on a high availability scenario. The last one I want to show you is about our specific features, which is something we call a data masking facilities. Let me just create a new database first. Doesn't like it. Sometimes it just happens. It has actually commit to transaction, but it's giving you error. But if you come back to here, looks at our schema and refresh the database, you can see the database is actually created. Although like PGME is giving an error, the database is created. Now I'm going to do some query. So data masking is a facility that we create as an extension to our FEP database. We just need to load the extension into the system, and afterwards we can mask some data. Let's run it. All right, so it's done. That means the extension has been loaded into this database, and now we can start doing some masking. All right. Okay, let's look at this SQL query first. So here we're going to create a table called masking, and it has a couple of columns inside this table. One of the table field is called the phone, which is going to store a phone number. And then there's another column is the date of birth, which is going to store someone's date of birth. So we have made some imaginary date for this one. And then we just try to execute it. You notice about the phone number is in a free text format, as well as the date of birth. So the next thing we're going to do is we're going to mask the data. So how are we going to do it? There are actually a couple of ways you can mask your data. We can do something we call a full masking. So basically it will mask the whole field with something different. Because this one is a date of birth, we will mask it with a totally different value. And then with the phone number, we can do a partial masking, and we tell it like how the field looks like and how we are going to mask it. Basically, we will leave the first characters as usual. The rest we will mask them. So before I execute this one, just go back to the previous screen. We see that this is the phone number. This is their birth. We come to this one. We're going to execute that SQL statements. Done. So it is the same table, the masking table. now you can see that the phone number has been masked and the date of birth has been changed to a different value. So this is very useful capability, especially for like financial institutions, insurance, or even for the GDP help, that sometimes the data stored on the database is still the original data. It doesn't change your data on the database. However, when we create a policy to mask the data, and when someone selected their data back from the database, it's all masked to according to a policy that you define. And we have a couple of different policy, so you can define your own policy, and depending on how you do it, the result is different. But basically, it's very useful. Like in situation like you have some kind of service agent that's dealing with the customer data, but you don't want them to see the whole information. Is that you just want them to see like the first 3 characters of the phone number and verify that with the end customer. So you can use this facility to help you doing that. So I've showed you 4 different aspects of our database. So it's quite easy to use. That basically conclude my demonstrations.